I hope this thing is on. And if you can read, I hope I don't just have a bunch of 2-year-olds watching this. This is a new thingy called space. And it is actually informative, and it's not just for fun. This will actually teach you stuff. So if teachers ever tell you that internet just rots your brain, that's not true. It might be true, I'm not sure. I'll have to research that. Anyway, it's about space. If you can tell, maybe. You might be able to tell with this word. Anyway, the first thing that you need to know about space is it is ginormously huge and is constantly, expanding in all directions. It's getting big. Also, this is going to be annoying, so just watch out. It's constantly getting bigger, which means that we're only going to be able to cover about 2 subjects in each video. So, do any of you guys know what this is? If you don't, it's the solar system. Also, if you don't know, go back to first grade science, please. Do not watch this. It will be way over your head. And do you all know what these are? Oh, you all know what these are? Hopefully you guys aren't quick readers because that probably just ruined my surprise. These are planets. Duh. Again, go back to first grade science if you didn't know that. But, does anyone know what's over here? What is all this junk? It's okay if you don't know. You can continue on watching. Somebody is probably thinking, oh, duh, it's nothing. It's all empty. 2 things. 1, there's always going to be little bits of matter all around. But also, this is full of antimatter, which is what we're going to be talking about. We're also going to be covering a little bit of stuff about black holes because black holes are cool, but they have nothing to do with antimatter. Okay, what is antimatter? Antimatter consists of antiprotons, which are protons, except for with negative charges. If you don't know about what protons, neutrons, and electrons are and about their charges, you probably haven't done 8th grade science, and you should probably go through 8th grade or try and remember some stuff before you watch this, because then it's all over your head again. But they're negative, and as everyone who has a brain knows, or that's been through 8th grade math, if you don't know this, you're fine. Protons have a positive charge. It's also made up of antineutrons, which have no charge, but antineutrons don't have a charge either. They're just weird. And then there is positrons, which are pretty much the opposite of electrons. And instead of having a negative charge, they have a positive charge. And this stuff is the opposite of normal matter. They're so different that, the polarities, the positive protons and negative protons, when come in contact with each other, are going to explode, which pretty much means if you put a normal atom next to an antimatter atom, they're gonna explode and probably kill you. Yeah, and they'll kill each other, so all good. And where is it found? Anywhere that matter isn't, at least in theory, which means that is absolutely wrong. I'm going to ask you to remember that circle way back in the solar system. Yeah, that's supposed to be teeming with antimatter, but it's not. There's no antimatter. There's probably a lot there, but not very much. What's supposed to happen is at the Big Bang, in the beginning, there was supposed to be 50% matter, 50% antimatter created. But scientists cannot find any antimatter. Maybe there's just galaxies and galaxies full of antimatter that we just don't know exist. But no antimatter. Now onto physics. These are like myths. Antimatter does react to gravity. It does not fall up. Like people think, oh, since it's opposite, it's going to fall up. No, physics work the same. Except for, let's say if we had a glove that was made out of matter, antimatter would not cause friction with it. We're just going to pretend it's a perfect world where things don't explode. And so if antimatter didn't explode normal matter, it would not cause friction on normal matter. So, to explain this in more depth, we're at a space football field. That is space. Yeah. And you're at a space football field. And let's just say you're Tom Brady and you're going to play some football. And let's say we filled this whole entire place with, instead of normal matter, and antimatter, and it's a perfect world where things don't explode. So Tom Brady's going to throw his football, and the football goes on for all eternity until it hits a wall. Okay? Because there's no friction. But if it was with normal matter, as you all know, oh, and also there's no gravity, okay? We're pretending that since we're in space, there's no gravity. It's going to stop at some point in time at the 10-yard line, and you're going to be sad. It's not a mustache. And we're done. That's it. Except for there's probably going to be some of y'all haters that are going to leave an angry comment in the comments section about how, oh, you didn't cover black holes. Well, bet. Yeah, what about black holes? I forgot. What are they? Black hole is essentially a dead star. It's caused when a star implodes. So instead of stars going to star graveyards to be buried by their star families, stars just decide to either explode, destroying a lot of stuff, or implode, destroying even more stuff. So yeah, stars, as you would say, go out with a bang. How does a star implode? There's a lot of ways to explain this, but most of them include physics and math, and no one likes math. Well, people do like math, but who cares? First, we're going to need to the simplest way is to explain how a star works, okay? Stars start out as just a pile of gas and star stuff. That's what it's called. And like everything, star stuff has gravity, and it's all going to clump together into a little ball at the center. Oops. And that gravity will slowly cause stuff to ignite, and that causes our sun. Now, let's just chop the sun into little itty-bitty pieces. And here we go. So the sun has a huge amount of gravity, and we're going to need to know how it shines to figure out how stars implode. But anyway, so it's pulling atoms towards the center, right? And sometimes once the atoms get to the center, they're going to collide. So two helium atoms, or I don't have a periodic table with me at the moment, but two helium atoms or something will collide to make a hydrogen atom. I think that's how it works. Don't hold me on that. And so on. And that collision causes a burst of heat and energy and light, and that's what powers the sun. And after a while, they run low on atoms to collide, and slowly, well, this is what happens. This works up until a point. Up until we get to a certain element. I believe it's iron. I can't remember off the top of my head. And the problem with iron is when two iron atoms collide, they don't create a huge amount of energy. So once it gets to iron, it's just slowly getting denser and denser and denser and not creating enough energy until kerblooey. Star explodes. And there's either two ways that this can happen. The star explodes, and then all the stuff around it slowly gravitates back together, and it implodes on itself, causing oh, you guessed it, it's a black hole. Which isn't really a hole at all. Or it just blows the top off of it and just leaves the core sitting there. That's called a blue dwarf star or something like that. Don't hold me on that either. I don't know stuff. I'm a dummy. But anyway, we're focusing on this guy, right? And now to understand physics of a black hole, we're going to use our Tom Brady example because I think that worked pretty well. And so he throws his football, and it's circles around, but not because the black hole's sucking it in. It's just because the black hole is gravity, just like everything else. It has more gravity than that because black holes are extremely dense, like denser than Tom Brady. Like really, really dense. And the black hole just goes in and it's intercepted. Interception! And Tom Brady is sad. And that did not cover the physics at all, did it? No, it did not. So we're going to take our little cool X-ray cameras and look at the inside of a black hole. There's our football. And so, it moves in, and that's where it is right now. And this is what it looked like to the naked eye. Just disappear. Just disappear. There we go. I hate when that happens. Lag. And so it's pass through the outer horizon, which is pretty much the area where light can no longer escape the gravitational pull of a black hole. And so it's slowly circling around. Now, it's not circling around because of the gravity or anything, or because it's moving. It's because the black hole is orbiting. It's spinning around really, really fast. And, yeah. And slowly, it's just going to spin around until, BAM! What just happened? Well, the football collided with this point of singularity. Point of singularity, which is right there. And the point of singularity is all that junk that's the black hole sucked in, well, not sucked, but gravitated in, and the remainder of the star. It's all super duper dense, and so when the atoms of the ball collide with it, it just causes an explosion. It sucks all those atoms onto it just to add to that mass, a density. And I believe someone asked, what happens when black holes die? Well, or do they die? Well, black holes do die. I'm just going to go back to that image. And I'm going to ask you to remember that circle way back in solar system again. I told you it was empty. It's not. One, it's full of atoms. Two, it's full of a few antimatter atoms. And then three, it's full of energy particles popping in and out of existence. And what happens is two particles will pop into existence. Then they will be drawn to each other because of gravity. And then, well, bam, they will hit each other and family feud it out and die. And that'll happen, and that's normal, and that's just the creation of and destruction of energy. But near a black hole, one will pop into existence, another will pop into existence instead of killing each other. Since the gravity is so big, it'll just shoot into the black hole, and the other one will go flying away. And so it just keeps on going flying away, and the black hole is slowly losing energy until it loses so much energy that it explodes, destroying galaxies. The end. It's a really, really deadly way to go. And like in card, I'd like to thank Kurzgesagt in a nutshell for being amazing. And I definitely could have sounded like I was knowing what I was doing. They've got two videos. I think it's called Black Holes and Black Holes 2. Black Holes. That's a pretty good impression. But you should watch those. They're pretty much the same as my video, except for minus antimatter. They really helped me sound like I knew about black holes a little bit, and you should definitely subscribe to Kurzgesagt in a nutshell. And last word, stay curious, because curiosity doesn't always kill the cat. And when the cat doesn't fatality the curiosity, sometimes it just learns to drive. Thank you very much. Goodbye.